Hey everybody, welcome back to Know Thy User, a podcast by Rival Mind. We are in the third part of our three-part series that we're calling The Sweet Spot, where we've been talking about trade-offs within finite systems and how are we going to allocate the resources that we have to be able to make awesome websites in our case. But today we're going to focus a little bit narrower on what we were calling complexity of design or features versus performance, which we were talking about before is mostly page load speed is how we're measuring performance. So Jared, talk to me a little bit about complexity of design and what does that mean as far as the sacrifice or the trade-off that you're trying to find versus performance?
Yeah, absolutely. So really the trade-off, I said this last episode, but really it's all about website performance is mostly about the amount of bytes you're sending to the person requesting your website. So as we add design features, we add CSS, which means that we're adding additional weight to the page.
Yeah.
Also very image heavy pages. That's a big, if you have a page with a ton of images, you're adding a lot of bytes and slowing down your site.
Right. So the play is, because honestly, the understanding of what our broad context is, like, we can't tell, I know that developers would love to, but we can't tell people when we're building their websites, hey, we really don't want to put these pretty images on there because, it's going to slow your website down.
Exactly.
So finding, okay, where is the sweet spot in that? What images are worth, being able to use those resources, those bytes, to be able to, make it so that this website is beautiful and engaging and has the marketing, back that it needs to, but also be performant. So different than complexity of design or just image heavy design, we talked off camera about features. Like, can you flesh out for us a little bit more about the difference between just design complexity and feature complexity?
Absolutely, yeah. So design is just going to be visuals, what you see when you hit the website. So these could be images, it could be a video playing, it could be crazy animations all over the page. But features are a task that is performed by the site. So it might be a scheduler, a calendar you can make an appointment on.
Right.
Any sort of feature that is done, performed by the application.
Right. So, we kind of tangentialized a little bit when we did this yesterday, but like one of the things that we talk about also that you were like, we could probably do a whole series on is rendering. And so we talked about server-side rendering and client-side rendering. Can you give me just a little bit of a breakdown without going crazy?
Yeah, absolutely. So on your website, you always have a server that is just a computer somewhere with an IP address sending data to the client, which is the web browser. So the client is HTML, CSS, and JavaScript. And JavaScript can execute and run in the browser. So it can do stuff. You can click and it can handle that click and perform a computation in the browser, which is really cool and powerful. But JavaScript is typically far slower than server-side languages. So when you shift logic from the server to the client side, you're making a trade-off. The page isn't going to refresh, but you're going to have worse performance in terms of speed and memory allocation.
So that makes great sense. So as we dive a little bit more into those types of where are you doing that logic, and then what is it that's handling the logic? We talked a little bit more about hardware and as things progress, like we used Facebook as an example, like being able to look at Facebook today and all of the activities or all of the client-side logic that's happening. It's like we wouldn't have even been able to see that 5, 6, 10 years ago for sure. You brought up a specific law that kind of pointed to that. Can you talk to us about that?
Yeah, so this law is called Moore's Law, and it's not a law of physics. It's not built into the universe. But it's just the observation that typically the number of transistors on a microchip double every 2 years, while the cost of computers goes down.
Right.
So essentially what this is saying is that hardware is exponentially getting more powerful.
Yeah.
Which is good news for us in software because we can continually add more and more features like Facebook and without a performance hit or as big of a performance hit.
Yep. One other feature about, what we're talking about right in that vein, you said WebAssembly. What is WebAssembly?
So WebAssembly is a cutting edge, you might even say bleeding edge language for the web right now that gives native speeds in the browser. So it's not stable as of yet, but is on the horizon, and that's going to really change the face of applications in the browser.
Yeah. So applications, I know at RivalMind we are building a data aggregation system. Can you talk to us a little bit about that?
Yeah, so at RivalMind we have a system that collects a ton of raw data from all over the internet, and we run studies comparing a website performance and SEO based on the markup of the HTML. And we have really prioritized, because of the volume of our system, we've prioritized speed and performance in that system. So we use a language called Rust that's bare metal, blazing fast, and is very performant and allows us to process a ton of raw data in reasonable times.
Yeah. So again, highlighting, pointing all the way back to our first episode, the amount of abstraction is very low.
Absolutely.
But because you have the technical capability to manipulate it, that's why we can use that. But performance is through the roof.
Absolutely.
All right. So this has been another episode talking about a large concept, finite resources in finite systems. Where are we going to allocate those resources? So we're trying to find the sweet spot. So that concludes our episode and our series. Thanks for watching.